Teletizens, back with me again, Aji Gautama Putrada. I am your lecturer for operating systems. This is our fifth meeting about concurrency case study. In the fourth video, we will discuss about producer and consumer race condition. Stay tuned. So in the last video, we have discussed about the program of the producer, which looks like this, and the program of the consumer, which looks like this, and we have executed an example in normal condition. And the conclusion of the execution is in normal condition. There are no problems. So the problems will arise in a race condition. So in this video, we will discuss about race condition of the consumer and the producer problem. So the race condition will look like this. This is exactly the same condition as in the last video. The difference is here when the producer produces and then fills, and then interruption happens because in race condition in concurrency, an interruption can happen at any time. So here an interruption happens and the consumer runs, it will run the consumer program, and then when it is done, it will go back to the producer program. Don't forget, before this happens, the buffer is initiated to I equals 0. So here what happens, the producer produces an example number here and then it will fill the buffer in, this is the buffer here, it will fill the buffer in I equals 0 with the produced number. So here, and then before it increments, the consumer takes over. It first decrements the I, so I is now not 0 but is decremented to -1. Here -1 is here, and then it takes a number which there is nothing here, and then another thing that this member of the buffer is not a member, not address that belongs to the buffer. So what happens here? We know that when we access an unallowed address, error will happen. So that is what happens when in race condition. So take and consume, this cannot happen because nothing is taken, and then when it goes back to here, I plus plus, I is now -1, it increments to 0 again. So even if the producer runs again, it will run at the same place, it will fill at the same place that it has it filled in the previous place. So it will be stacked at the same uh, memory address. So what is the conclusion of this story of race condition? Here, conclusion is that when the producer runs, it cannot be interrupted, meaning that this is critical section. And we can imagine if the consumer runs and it is interrupted by the producer, a similar thing will happen by the interruption. So this is also a critical section. meaning that this path needs to be protected by the semaphore. So that is the end of video 4. In this video, we have successfully discussed about the race condition of the consumer-producer problem. In the next video, we will implement a semaphore to the producer and the consumer, so mutual exclusion can be implemented. Thank you for your attention. I'll meet you in the next video.